Now recording. So, here we are again. Are there any questions about anything before we get into the lesson? Good. Everything seems understandable so far, but we haven't actually covered anything, so it goes. So the first thing that we need to sort out is what software we will be using in this class to write code. So software development, technically speaking, does not require any of the tools which we are about to use. All you really need is a plain text editor like Notepad, or I forget what the Mac one is, but since it's Unix, you can probably pull in any of the Unix-based ones. A plain text editor and a compiler. That being said, plain text editors are, they have none of the modernizations which allow one to program with additional, information, fluidity, perhaps some helpful suggestions. One of the things that it's extremely useful to have is an editor which knows what the built-in library functions you might call are and can do autocomplete suggestions. This type of thing is extremely common. Most people who are programming in any a professional capacity will use one of these tools as opposed to doing things sort of bareback on a plain text editor. That being said, it's always useful to have a plain text editor in your back pocket when programming, because we do not program in Word documents, right? Everyone has seen Notepad before, right? Anybody not seen Notepad before? This thing? Notepad? So, the interesting thing about... Hello, welcome. So the interesting thing about Notepad... now hold on just a moment here. I'm counting 9 in the room now. Who wasn't here on Wednesday? Yes. There will be, as soon as I get back to my office, I will be uploading. I took a video recording of Wednesday's lesson, and you can watch it through at your leisure. It's organizational details, a bit of an orientation on the college, so yeah. But we must move on. So, plain text is a very important concept, like a foundational concept, when you're doing any kind of programming. Files on a computer come in many different file formats, but you can collect up all of the files on your computer, and they fall into 2 main categories. All right? First, you have binary files. These are binary encoded files. Examples of these sorts of files are image files or music files. And then you have text encoded files. Text encoded files include things like your Microsoft Office, documents and spreadsheets and things like this, and programming source code. Right? How many people are familiar with the binary system? Okay, so it's, if you're going to program a computer, you should know what a computer is. So the binary system refers to the manner in which computer memory is stored by the system. If you take a computer apart and you look at the individual parts, you have memory systems, random access memory, and read-only memory. Your RAM, download more RAM from the internet, etc. You can't actually download more RAM from the internet, it's hardware. And then your hard drive, which is read-only memory. In both cases, what this hardware actually is, it is some way of storing high and low voltage states, right? So if you break apart your RAM and you take a very, very fine microscope and you look at it, you will see a gigantic array of memory cells done in transistors. These memory cells are electrical components. The electrical components hold either a high voltage corresponding to a 1 or a low voltage corresponding to a 0. So, at the end of the day, every single thing inside of a computer in some way breaks down into ones and zeros. The image that you're seeing displayed here, the contents of this file, the fact that the cursor is located at this position on the screen, I turn those pixels black, etc. All of this information is binary information. That's not quite the same thing as being binary encoded information. Binary encoded information means that the file stores native ones and zeros. Text encoding means that those ones and zeros are arranged to represent characters. Characters are a very important concept. We are talking about the fundamental building blocks of files. Everything in a text-encoded file is a character. A, S, D, F, these are all characters, including things that don't necessarily look like characters, like spaces. Space is a character. See how I can highlight it? That thing right there, has a binary code. That code is saved into the file so that we can know where the space is, right? When you press enter, you get the same thing. What this does is it inserts an invisible new line character into the file. Is this making a certain degree of sense so far? Any questions? You may have had some inclinations about these types of ideas just from osmosis. But, so, this is what's known as the ASCII chart. All of the numbers 0 through 127 for 7-bit ASCII encoding correspond to some character or some operation, right? You can see that, for example, we've got horizontal tab, which is the tab key, mapped to a decimal value of 9, right? If you look inside of a text file, all of these numbers are there, whether or not the computer is choosing to show it to you as text, right? Long story short, everything is numbers. Everything is numbers. Even if it looks like it's not numbers, all it is a fancy way of showing the numbers so that, us poor stupid humans can read numbers without actually having to read numbers. So, everything is numbers. Write that down. Everything is numbers. Question?
Do we actually have to know the numbers of the...
Oh, heck no. No, you don't have to memorize this chart, don't worry. There's some interesting stuff in here, though. The ASCII encoding actually, it originally derives from electric typewriters, and there are some operations encoded in here which only really make sense on an on a typewriter. Like for example, carriage feed. The carriage used to be the roller that you would put the paper into the top of a typewriter for. So there was an actual character encoded in the format for, feeding the carriage forward by one line. And there's also a carriage return in here somewhere, and bell as well. So, it used to be on older computers when you printed the bell character, the computer would beep. But I don't think they do that anymore, much to my sadness. But anyway, this will get, you may be asking yourself, why am I learning about this right now? I thought we were supposed to be doing programming. This is how you have to think about data if you are to work with one of our very important fundamental data types, which is the string, or the string of characters. All right? The first data type that we will be using when we write our first program will be a string. And it's important for you to understand that a string is a sequence of numbers interpreted as characters. Okay? Just like files are sequences of numbers interpreted as characters. So, with me so far? Any questions? Okay. So, the thing which I'm kind of gradually working myself around to is, why can't I use Microsoft Word to write a program? Right? Well, many of your sort of standard editors, your Privacy Matters, huh? Yeah, I bet. If I were to write programming code in something like Microsoft Word, the question is, am I editing plain text or am I editing something else? So, for example, hello, this is a program. Not really. Save that. It's so insidious how the default save location is the cloud now. There we go. Saved to this PC. Yeah, good. And documents. Hello, this is a program. So, when you have a file, double-clicking on the file will open the file in whatever program the system has decided that file should be associated with. If it's a .docx, it's basically there's a big registry table inside the operating system that says, okay, this file extension should be opened by this type of program. So that's what the double-click operation is. But you can actually open any file in any program. If you right-click, open with, more apps, select good old Notepad, our plain text editor. Well. That doesn't look like what I wrote on the page, now does it? So it's very important to understand when you feed a file into a compiler to be turned into an executable program, it is looking at this garbage, right? This is what a Microsoft Word file looks like. Our original text can't even be found in it. So we don't know what to do with this. How is the compiler supposed to figure out what to do with this? Right? As opposed to something done in a plain text editor, like this, which actually is, in memory, what you see on the screen. right? Does that make sense? So far, so good? Okay, question?
So if you write it in Notepad, you can open any program, right? Any app, there's no problem.
Yeah, let me show you. So, and very model of a modern journal. Save. Save to documents. Call this general notes.txt. It's okay, you can laugh, that's a joke. So when you ask to open it in Word, it's filtering for actual Word documents. But if you click All Files, there's generalnotes.txt. Open it, and there it is. Now, if you resave this, Word is going to add all kinds of junk into it, right? Which you don't want. So that's why you do not program in Microsoft Word. We have better technology. So let us now examine one of those pieces of technology. So in general, there is 1,000 million different code editors which you may use. Who are the people with programming experience in the class? Right. Which editors do you prefer?
Visual Studio.
Visual Studio? Yeah.
Yeah, just like
Same?
a little bit of Visual Studio.
Yeah. Anybody, either of you use VS Code?
That's what I think I currently have on my laptop.
Mm-hmm.
It's not what I used to use, but when I just got a laptop recently, so I downloaded it.
So Visual Studio is like, that's the one that I'm about to show. It's quite bulky. It has a lot of features, but it also has a lot of features that you might not want, you know? Visual Studio Code is basically Visual Studio saying, oh, it looks like quite a lot of people are like not using Visual Studio in favor of like just a smaller, lightweight text editor. So it's like, well, we'll make a small, lightweight text editor, and they can, if they want extra stuff, they can put extensions in, and that's basically the design impetus of Visual Studio Code. Again, there are 100,000 million of them. As you become a programmer, you will have one that is your preference, and basically, like, you want to pick one, learn its features well, and then like stick to that one, because you don't want to have to relearn your editor every 3 months, you know. Question?
Do you have a preference if we use Visual Studio Code or Visual Studio?
I personally do not care in the slightest which one you use, except when we get to like Windows Forms type stuff at the end of the class, where that kind of has to be in Visual Studio, because it's, well, you'll see for obvious reasons. It's got like the form layout thing where you click and drag and that kind of stuff. But like for just plain general programming, the thing I use most in class is Visual Studio Code. The thing I use most myself when I'm programming, you know, for pleasure, when I'm doing my own stuff, I'm usually using something Linuxy. So, you know, because I'm a Linux guy, even if I have to suffer the installation of Microsoft software on my pure Linux machine, I can at least not use it as much as I can in favor of the free and open source software. But anyway, so is everybody logged into their lab computer? Yeah, you're well. If you probably don't have it installed, right? Or maybe you do.
Which one?
Visual Studio.
Oh, I do have that one.
Well, in that case, you can use your. So click the Start menu, type Visual Studio 2022. Enter. It will take a moment to load. You do not have to sign in or create an account. Choose your color theme. You should always choose dark. Always choose dark. Anybody know why you should always choose dark theme?
It's better for your eyes.
Yep, it reduces eye strain. You are computers professionals. You will be looking at screens for most of your lives. You can at least, try to do a few things to reduce eye strain, one of which, use the dark theme. So, Visual Studio 2022. You will notice you have a few different buttons here, including opening previous projects, cloning repositories. You probably don't have to worry about cloning repositories just yet. But let us create a new project. Right at the top there, you will see C# console app. So, what a console app is it's a program designed for a command line interface. That is to say, it's just going to be a program that spits out text. This is much, much, much simpler than the other program that we're going to be using, which is Unity, which is a full-blown video game development environment. So, let us create a new console application. Give it, week 1, whatever name you want. Location, so orientation thing that perhaps I forgot to mention last time. It will be useful for all of you to have a portable hard drive, because as you can tell, you're not necessarily all in the same room every time. Basically, do not rely on these computers to store your information, at least to the hard drive. You do have a certain amount of network storage, but once you start dealing with virtual machines and that sort of thing in later classes, the amount of storage that you get on the network is swiftly going to become titchy. So, I recommend getting yourself a nice, generous external hard drive, preferably an SSD. Actually, I'm not even sure you can get spinner disks for external drives anymore. But yeah, get an SSD, USB compatible, obviously. Don't just get yourself a SATA drive. Yeah, and keep all your stuff on it. Start it now. Get in the habit. Anyway, create the project. Framework, don't worry about that, just click create. So, at some point I'm going to have to turn off the suggestions because they just annoy me. So, we are presented by default with the line console.writeLine hello, world. This is the hello world in C#. If we execute this code, there we go. You can see we get a little console which is a little command line interface, it spits out hello world, and then it finishes. So let's break down the statement a little bit. C# is an object-oriented language. One of the ways that this presents itself in the code is you're going to see dots. You're going to see a lot of dots, particularly once we start getting into Unity. This little guy here. It's not a period. That is an operator. All right? You guys know what an operator is? It's like operator in the mathematical sense. In the same way that the addition sign performs an operation on two numbers, this little dot performs an operation on these two phrases. It links them saying, I want to use the WriteLine method, which is a sub-element of the console object. So, using dot notation, you start with the object at the high level. You then use dot to specify what element of that object you want to work with. So the console is the console itself, right? It's the interface through which the text is being written. The WriteLine method does what it says on the box. It writes a line to the console. Make sense? So far, so good? Hello world. This is a string. You remember that boring part where I was talking about the characters and I brought up that big chart? These are the characters, right? A string is correctly understood as a collection of characters. HELLO, comma, space, WORLE, exclamation point. This is different than the characters which compose the file itself. The thing that distinguishes the string from the programming code itself are these quotation marks. So, let's see what happens, just for the sake of argument, if I remove said quotation marks. Well, first of all, we know we get a whole bunch of red underlining oops, right? Spell checking. It's not spell checking, it's syntax errors. Syntax is the word for it. But, you know, immediately the system is complaining. What if we ignore that and try to run it anyway? There were build errors. Would you like to continue and run from the last successful build? No. There we go. I'm giving a lesson. You're being too helpful, Visual Studio. So, this is a very important thing to know. When your program has problems, those programs, the problems with that program will show up in the bottom pane. You will get error messages. The interpretation of error messages is an absolutely critical skill when it comes to programming, right? If you can't fix an error from an error message, you need to come to me and I will show you how to do it. Because, you know, basically, a programmer who can't fix syntax errors using error messages is no programmer at all, right? And while this is an interdisciplinary degree with 3 different aspects, you are going to be expected to be able to produce a working code by the end of it. So, you know, We are trying to give you not just an academic knowledge of how to program, we are trying to give you actual, hard, physical, real programming skills, which means you gotta fix errors, and you will be presented with lots of them. Alright? So, let's read these. Number 1, the name hello does not exist in the current context. I appreciate that this text is very small and difficult to read from the back, but so I'll just read it to you. First error, the name hello does not exist in the current context. Second, the name world does not exist in the current context. So, what on earth does that mean? Yes?
It's trying to, it's like the words hello and world are undefined as variables, so it's trying to draw from it, but you haven't defined it.
Is that what you were going to say? Yeah. Not necessarily variables, but like elements of the language, right? So, without the quotation marks, it thinks that these are basically first-class citizens of the language in the same way that console and WriteLine are, right? It's like that's the category it's drawing from to try to interpret these words. It's now seeing them as elements of the language rather than a piece of data, right? So, or I suppose several pieces of data, one piece of datum. Because, you know, most people don't know this, but the singular form of data is datum. But anyway, so basically, if you leave out the quotation marks, this gets interpreted as programming code rather than as the data you wish the program to operate on, right? So that's why it's very, very important to put the quotes in at all times, at least when you're talking about string data. So, let's talk about the parentheses. So, to muggles, these are called parentheses, but to programming wizards, these are called round braces. The reason we call them round braces is because, as programmers, we must deal with several types of braces. We have round braces. Get out of my face. Settings. No, 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 no. Okay. Thank you. Good. Round braces have various uses. When you're passing information to a method, you use round braces. Square braces. Square braces are often used when you are working with data structures, things like arrays or lists, multi-dimensional lists, all of that kind of thing. Braces will allow you to extract information from an array at a particular index. You don't have to worry about memorizing all of this now. We will, of course, come to all of this when we hit it in the material. Curly braces are one of the most frequently used braces. You must understand curly braces. What curly braces do is they designate blocks of code. This is a necessary operation when you are writing any type of control structure, such as conditional statements and repetition statements, which we might not get to today, but I think we can probably at least get to if statements. They say, not at the pace you're going. And then, rarely, you will see angle braces. Any of my programmers in the crowd have any idea what angle braces mean in a C# context? We will see them in Unity, though we will probably not understand them very much. Type generics, or type variables. Angle braces allow you to pass types as parameters to methods and classes in the same way that round braces allow you to pass actual hard data. But again, we'll see that, but most of you will probably just memorize stuff about how to do stuff in Unity because type generics are like an advanced topic. Which kind of brings me to another point. When you are programming, you will often be dealing with more advanced things that you don't have enough programming skill to understand, but you still have to write them. So there is a certain amount of you just have to memorize stuff and wait a couple of years until you have a better appreciation of the discipline, and then you can kind of begin to understand what the hell is going on. So if you don't understand something and it works to just kind of memorize it and barf it back up into the editor, then that's good enough for now. I am not expecting any of you to have a complete and whole knowledge of anything, especially right now, because we're only what is it, half an hour into the first class, but even by the end of the course, like programming is a very there's a lot going on, right? And it's unreasonable to expect any student of programming, even if they've been doing it for some time, to know everything there is to know about programming. It's just not feasible. There are thousands of languages, right? Now, while it is true that there's a great degree of overlap in the knowledge from one language to another, particularly if there's languages in the same paradigm, each language has its own little tricks. It has its own little tricks, it has its own little, different ways that it likes to do things. And, just because you have learned a little bit of C# in this class, it doesn't make you qualified to, it doesn't automatically qualify you to use any other programming language. And I'm not even sure that I would be comfortable with you folks putting C# on your resume after this entire class by the end of it. Because the level of C# knowledge that you would need to have for an employer to think, oh, this person's put C# on their resume and they actually know C#, so they didn't lie on the resume. It's more advanced. You need more practice than what you're going to get in this class, right? It's probably, if you have a section on your resume saying, I have dabbled in, then I would put, Unity and C# in that category after this class. Particularly if this is your first programming exposure whatsoever. And I'm not trying to be mean or anything, I'm just trying to give you some kind of impression of the depth of, the endeavor that you're embarking on. Any questions? Not trying to scare people. Well, maybe that's not true. Yeah, maybe I'm trying to scare you guys just enough to take the class seriously. But anyway, so in this case, we are using round braces. We are using round braces to pass data into a method. A method is an action, right? You can tell that it's an action because it uses a verb, right? Console is a noun, write is a verb, so this is a verb applied to a noun. It is, I am performing this action on this thing, right? That's how object-oriented kind of likes to think about itself. And then finally this thing. Anybody know what this thing is? Grammatically, what is this? Everybody at the same time. What is this character? 1, 2, 3.
Semicolon.
Right. It It depends on the language. Sometimes semicolons are required as line terminators, sometimes they are not. In C#, the semicolon must be at the end of every line that doesn't have a curly brace and isn't blank. Anytime you are writing a statement, and this is a statement, you put a semicolon at the end of it. Any questions? Okay. So, here's another example. Right? If I run this, and this is one of the reasons that people hate Visual Studios. This is taking too long. Like actually, like run. There we go. Hello world, goodbye world. So. All right, sounds good. So far, so good. This is how you print information to console. Once we switch over to Unity, it will be very similar, but rather than saying console.writeLine, we will say debug.log. As Unity considers itself to have a debug pane rather than a console pane, and log is because it's writing logs instead of writing lines. It's they are synonyms. It does the exact same kind of thing. The terminology will differ depending on what programming environment you're in, and that is something you should come to expect when you're dealing with programming languages. Functionally, they do the same thing, mostly. So shall we talk about data types then? So, strings and characters are, oh, yes,
So I
question.
have one more question. The Unity, is it like a different language or what is it exactly?
That's an excellent question. Unity is an integrated development environment for video games. So, in the Unity environment, what you're doing is you're making game objects. But Unity contains the ability to add dynamic behavior with scripting. So you can write a script, attach it to a game object, and then that script runs and does something programmy to the game object, right? The language which Unity uses for its scripts is this one.
Okay,
Does that make sense?
makes sense. So do we use Unity for every game consoles or is it like some game consoles?
So Unity is quite strongly cross-platform. You can compile it to any game console you wish. In terms of the sort of games that it usually gets used for, it's usually used for like mobile game development, as I understand it. Like, if you want something that looks realistic, you go with Unreal Engine, ironically enough. Unity is like those mobile games where it's like mob control and you have all of these little stick figures running and like there's like ragdoll physics and that kind of thing. I would put money on it being a Unity game, basically. Unity is kind of considered to be like within the game industry, it's kind of considered to be like the sort of mid-engine, if that makes sense. Also, there's been like some like kind of scummy business practice going on at like Unity at the top levels lately, which, you know, developers are kind of like thinking about ditching Unity type thing at the moment. But that being said, it's still a perfectly usable game engine. You can get Unity to look as good as Unreal. You just have to work harder at it, basically. Lots and lots of things were made in Unity, even famous things, although I can't put my Flappy Bird was made in Unity? I don't know, possibly. No, well, I don't know. It'll show you, kind of show you how long it's been since I followed such things closely. But you guys remember Yooka-Laylee? Like the Playtonic, you know, the old Banjo-Kazooie guys went and formed a company and tried to do the thing which everybody does, which is make a new game from like an old successful thing from the 90s. They're trying to recapture the success of the 90s and fail to do so in some way or another. Unless it's like a one-person project, that's like the only Kickstarter projects that actually work, or one-person projects. Anyway, I'm pretty sure that one was made in Unity, but anyway, it's fine. It's fine. The reason that we're actually like, you may be asking yourself, what on earth does game design have to do with digital health, right? Fair question. Next question. No. So it kind of comes down to what the current thing was when this program was designed. You may remember about, 10 years ago, there was the AR, VR craze, everybody was like, ooh, I'm gonna get like this cheap little plastic headset, put my phone in it, and look at that visual, 3D. And like, the Oculus Rift came out at that point before it was, it's been renamed now, hasn't it? I'm pretty sure. It was bought by Facebook, which has also been renamed. But anyway, so at the time, people were very excited about the research possibilities, the possible future of AR, VR. Now, of course, everybody's, that was like 3 new crazes ago, right? But basically, Unity, at the time, one of its selling points was that you could do VR in it reasonably cheaply and easily. Just, some configuration settings, load a module, and you can compile to like a virtual reality headset. So that's why we do it in this program, because virtual reality is considered was considered a active research area. Whether it still is, I don't know. Research is kind of this notoriously frustrating exercise in trend chasing, but you're probably, if you're just trying to get published, you're probably looking for some kind of application of AI to digital health these days, right? Because everybody's losing their minds over that right now. It's all marketing. It's all hype. It doesn't do that much more than it did before. Anyway, don't get me started on AI. Don't do it. So anyway, does that answer your question?
Yeah.
Awesome.
Thank you.
So data types. Strings are a data type. We have a couple of other important data types. Since everything is numbers anyways, you might expect us to have some data types for numbers. These roughly correspond to, from your math classes, the integers and the real numbers, right? So we have a data type for integers, which is called int. Int x is equal to 5. It's just complaining here that x isn't used. And then we have real numbers are a bit more complicated. So let's just talk about integers for now. So an integer, can anybody define for me what an integer is? Oh, come on.
It's just any number doesn't have a decimal, it's rational, it can be negative.
Yeah, it's a positive or negative whole number. Yeah. Not to be confused with the natural numbers. What are the natural numbers? Yes. All positive whole numbers, including 0, because 0 is neither positive nor negative. So, when I say int x is equal to 5, on this line, I am declaring a variable. Now, variables work very differently here than they do in algebra, right? It's important to understand the distinction. So, what does a variable do in algebra? Anybody? Yes?
Essentially like a placeholder, kind of.
Mm-hmm. Yep. So a variable is a number which might be any number which we constrain with formulas. If we constrain it enough, that constrains it to a single value, and then we can solve for x, right? Variables in a programming sense are memory locations. So they are variable in the sense that the value at this memory location can change, but they are never underdetermined, right? You guys know like underdetermined equations, right? Like x plus y is equal to 7, right? Although this gives us some information about the values of x and y, this gives us some impression of what the relation is between x and y, we cannot actually determine a hard physical value for x or y because several values will solve this equation, right? You know, x could be 2 and y could be 5, x could be 1, y could be 6, etc., etc., etc. There's actually an infinite number of x and y values that will satisfy this equation, right? This is not how things work in a computer. Computers, and this is a very, very, very important concept, so please pack this into your brain, all right? Computers are physically existing devices and therefore cannot contain infinity. Right? I mean, it makes sense when you put it like that, I hope. Like, this thing is not infinitely large, therefore cannot contain an infinite number or an infinite set of numbers. Right? When we assign a variable, first of all, this part creates the variable, right? What this is saying is, okay, I am the program, I am talking to the operating system. Hello, operating system. I would like to kindly and cordially request that you give me 1 integer's worth of memory in your RAM, pretty please. And the operating system says, yes, I think I have space in my RAM for your small integer. Here you are, here's an integer location at memory address X03335721. at something like that, right? That exchange is handled in the back end by the compiler and the system that's running the program. You don't ever have to touch it. All you have to know is this thing assigns to this program some little piece of memory. It's a little hole in the memory, it's a little slot the size of an integer. The second part here is it's saying to the memory system, this little memory slot that the operating system just gave me, I would like you to put the value of 5 into it, please. And the memory system is like, yes, absolutely, that sounds like a wonderful idea. I will take your 5, I will put it in memory, I will store it until the computer is turned off or the program is deallocated, and you shall have that memory, sir. So, that is the exchange going on. 5 gets assigned to a location in memory within the context of this program. That memory location is named X. So, it cannot be an infinite sequence of possible values, right? It is always one specific value, right? Because when we say, I want you to give me a piece of memory the size of an integer, the size of an integer is actually bounded. So, if you take the mathematical definition of an integer, what is the largest integer? It's a trick question, because they go on forever, right? Infinity is close to the correct answer. What is the largest what is the largest finite integer? That's a question. Anyway, so integers go off to positive and negative infinity in both directions, right? It's not possible to store infinity in a finite machine. So what do? We cut it off. We chop off the range, right? So everything is stored in ones and zeros. The binary system works like this, all right? If I have a number composed of ones and zeros, how many do I have? Let's make it 8, because computers love base 2. Anything that's base 2, a computer loves that. So let's say we have a number, right? This is a number in the classical sense. We apply place value here the same way that we do with a number encoded in Arabic numerals. You guys know what Arabic numerals are, right? Yeah. Anybody not? That's just like the number system that we use in math. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the place values in, like the numbers themselves are the Arabic numerals, as opposed to like Roman numerals, right? So this is a series of values at particular place values. Big difference. Whereas in natural mathematics, the base of the system is 10, because people have 10 fingers, even though the thumbs are technically not fingers. I know, right? What is the base of the binary system? Anybody want to care to guess? Correct. The base of the binary system is 2. So, whereas in a decimal mathematical sense, you've got 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 as your possible digits. For the binary system, you have 1 and 0. Only 2 possible values. But, so that's the number of digits we have. second important thing. If I were to write a number in natural mathematics, such as 432, hundreds, tens, ones, right? We have kind of an intuitive sense of this developed, but what this actually what the number breaks down into is 4 times 100 plus 3 times 10 plus 2 times 1. And if you're not familiar, in programming, asterisk means multiplication. So, that's what that number is actually doing, right? Place values, hopefully y'all got this in like grade 3, right? What they didn't tell you in grade 3, what this actually is, and oh, by the way, that's exponent, right? What this actually is 4 times 10 to the power of 2 plus 3 times 10 to the power of 1 plus, there we go, plus 2 times 10 to the power of 0. Right? This is the base. This is a decimal system. This is base 10 math. When we are working with binary mathematics, the base is 2. So if we were to take, and I'm gonna take like half of this one because I don't want to write that much. Oh, by the way, side note, these 2 lines that I'm putting at the beginning of each line here, this is what's called a comment. It's a way of like toggling, okay, this is not code, right? It's like, this is just a comment in the file, it's just been written into the file, it's not intended to be interpreted as programming code, and in fact the compiler strips it all out before it tries to execute the program, so I can just write whatever I want in a comment. That's why this is obviously not programming code. Make sense? Comment early, comment often. Commenting is a very good practice. Anyway, so if I have a number in binary, like 1010, that will be 1 times 2 to the power of 3 plus 0 times 2 to the power of 2 plus 1 times 2 to the power of 1 plus 0 times 1 to the power of 0. If we compute that, we end up with 1 times 8 plus 0 times 4 plus 1 times 2 plus 0 times 1. Computing just the exponents. Which of course leads us to 8 plus 2. So 1010 is equal to, in decimal, 10. Does that make sense? Sort of? Maybe a little? Hopefully a little? Time for a programming joke? Get it?
There's 2 people.
Yes, exactly. In binary, that is 2, right? So, okay. So now we have at least a vague concept of how numbers get encoded in a computer. Right? This is how integers get encoded. Question? Okay. Y'all better be careful with the hands, because like I'm pretty snappy. So, don't ask me how negative numbers work, because that's an entirely different discussion. Let's just worry about positive ones for now, okay? And we'll just assume the negative ones work. I can tell you, but I won't. Not yet anyway. You're not ready. It's too far. It's too far to go in the first lecture. So the question is, how do we take the integers, compress that down to something that's finite that we can put into a computer memory system? And the answer is by limiting the number of bits that can compose the number. Right? The consequence of this is that there is one largest number which can be expressed as an integer. The trick is, it's big enough that we don't have to worry about it most of the time. So, most of the time, depending on where you are, an integer is 32 bits, which means that the largest number that can be represented in 32-bit math is 2 to the power of 32 minus 1, which is 4.2 billion, which is, still not enough to represent the total number of humans on the planet. So you might be saying to yourself, perhaps I need a larger number. If you find yourself in a position where you need more bits than that, you can use a long integer. Long integer is another data type. Basically, long integers work the same way as a regular one. They just take up more space in memory. They take 64 bits. 64 bits gives you 1.8 times 10 to the power of 19, which is quite a lot. That's a fair amount. The way that it works is every time you add one more bit to a number, you double the range of that number. So after 32 additional doublings, that's how far you get, right? Which is probably a big enough number for most purposes, right? We're kind of getting into number of seconds that have elapsed in the known universe kind of territory with this, right? Age of the universe in seconds is I was really hoping to get something in scientific notation. Oh, there it is. Thank you. That's not at all what I asked for. Stupid thing. Okay, so assuming that, reading this very quickly is correct, 1 times 10 to the power of 21 is the age of the universe in seconds so far, which, we're a couple of orders of magnitude off, but, we're kind of in that range. All right, so integers. That's one data type. But the integers, they're all well and good, but, completely incapable of representing something like 3.2, which it is also useful to be able to represent. So, we have actually a couple of formats which can represent the real numbers. The way that real numbers are represented in computer systems, which is sufficiently complicated that I'm not going to get into the details, but it's called floating point arithmetic. Right? You nodded your head as if you've heard the term before.
The word floats before.
Yes. So float stands for floating point arithmetic. The general summary of floating point arithmetic is that it's an attempt to recreate scientific notation within the confines of the computer system. So you have some number of bits representing the fraction component, or like the number itself, and then a certain number of bits that are reserved for the exponent and of course because it's base 2, it's not, x times 10 to the y, it's x times 2 to the y, right? Because binary. So that's like roughly what float is, but a floating point number allows you to represent fraction, or things with decimal components, right? Fractions or something else completely. Float. Y is equal to 3.2. Now, you may be saying to yourself, ho, it looks like my poor benighted professor has introduced a syntax error. What could this possibly be? Well, as it turns out, literal of type double cannot be implicitly converted to type float. Use f suffix to create literal of this type. So, floating point numbers are of a specific size. The float itself is a 32-bit number. For floats, this is actually kind of small. Especially like when you're taking these bits and you're breaking them into like the one component and the other component, have another bit for the sign, whether it's positive or negative, you start running out of bits pretty quickly. They have a more limited range. So, the often used standard size for a floating point number is actually 64 bits. And this is called a double precision floating point number. That is the full term. Most of the time, they are just called doubles. So if you're wondering, I'm not doubling y, right? Double stands for double precision floating point number. So basically it's just a real number, but slightly more exact in ways that you probably don't need. Is this making sense? Sort of? Maybe a little bit? Hopefully? And again, we are assigning to a freshly created variable. Incidentally, you can actually split this up. You do not have to assign to a variable immediately upon its creation. You can say something like double z is equal to 7.8. This is still perfectly valid. All I'm doing is declaring the variable on a different line from where I use it. Make sense? Sort of? Maybe a little bit? See a little bit? Okay. One more data type, and then you guys can try some exercises. Which one am I going to talk about, programmers?
Well, is it like pi? Like an irrational number that's infinite?
Pi is a constant. So, pi is a constant and not a data type. Which data type am I about to talk about?
Integer.
Correct! We are going to talk about Booleans. So, don't let the name intimidate you. All a Boolean is, it's a true or false value. So you might think of these as logic variables. So, bool, q is equal to true. There we go. You can actually use the words true and false inside programming code. These are considered literals because they are literally what they say they are, right? When I say 3.2, I literally mean 3.2 the number, right? So that is called a literal. When I say true, I mean literally the value true. So it's the truth literal. Does that make sense? So you get true and you get false. We have various logical operators which can, transform these things in various ways, but so far we are not even within 1,000 miles of talking about operators. We are still talking about just getting data into the machine. So, any questions? All right. Write me a program, all of you students, write me a program which declares two variables of type integer, adds them, and then displays them to the console. I will give you like 5 minutes. For those of you who already know how to do this kind of stuff, don't worry, we will get to interesting stuff later. Probably not later today, though. I want you to show the sum of those two integers. And I don't care how you get there.
So I'm supposed to use numbers
You're supposed to use numbers.
but with words, is that right? Like, what? Because you said coding, everything is numbers, but we use words.
Oh, yeah, you're like the program itself will be characters. Yeah, just copy the line and
Okay.
make modifications. No, when you're programming, you don't have to just program in binary. That's what people had to do in the 60s, but we have advanced since then.
Putting inside equation 5.
Okay, so declare two integer variables, and then use a write line to display their sum to the console. I assume you have it already.
Does customization matter?
Is what?
Capitalization matters, it's kind of,
Yes, it does. Like,
the console and writing this word.
the problem you're having is that test doesn't exist. It's just at the top of the stairs. If you put everything in comments, it won't run.
Okay.
So, delete the comment characters. Comments are only for when you're not writing programming code. Since in this you're writing programming code, you don't want comment characters. Is complaining that you're missing semicolons. Also, I think you might have insert on. I think your editor is in insert mode. Yeah, that's why it was overwriting things. So, see this button?
Yeah.
If you press it, it puts the cursor in overwrite mode. See?
So that's how that.
Yeah. Well, I mean, the times when you like, I'm not saying there's no use for insert mode.
Yeah.
It can be useful, but like by default it should be off. Unless you're intending to use it, you're probably expecting it to be in like. Well, technically, it's well, you're in insert mode by default. You're in overwrite mode if you press insert to turn insert off. So it's an old typewriter thing or an old electric typewriter thing. I mean, it goes way back. It trips people up. Yeah. Cool. All right. So I actually, I skipped a step for this example. You had to do something that I didn't actually show you how to do. I wanted to see what your intuitions were. I wanted to see how reliable your intuitions were. So, I guess we'll, yeah, there we go. So, let's talk about the equal sign. In the same way that variables sound like they should be the same thing from algebra but aren't, so too our poor friend the equal sign also doesn't do quite what you would expect him to do if you were bringing your knowledge over from algebra, which you should, because knowledge of, algebraic knowledge is foundational to being able to program. So, what if I were to say x is equal to 10, what am I doing?
You're setting a value for x.
Correct. I am setting the value of this memory cell to the value of 10. Now, in arithmetic, it doesn't matter which side of the equal sign I use for this. The statement 10 is equal to x is precisely and exactly similar to x is equal to 10. Does anybody know what that mathematical property is called? I will just tell you, commutation. That is the commutative property of an operator. If you can take the two operands, swap their positions, and it means the same thing, then that means that it is a commutative, as like commute, as in the commutator on an electric engine. That's what that is. Addition is commutative under standard math. Subtraction is not. Right? Multiplication is, division is not. Normally, equality is, but here it is not. The equal sign is best thought of as an assignment operator. Instead of thinking in your head, x is equal to 10, what you should be thinking is, I am assigning 10 to x. Right? That being said, it's very difficult to not to drop into thinking of it as being equals because, you've been working with equal signs for a very long, as long as you've been doing math. So, far be it for me to tell you that the equal sign is not the equal sign, right? But it's not making a statement about equality. It is not saying that prior to arriving at this point, x was equal to 10, which is what the equal sign does in standard mathematics. At best, it's an assertion. Here, we are saying, I want to take the memory cell designated by this variable named x. I wish to place into that variable the value 10. So, if you think of memory as a series of cardboard boxes into which you're putting cookies with numbers on them, when we put the cookie with 10 written on it into the cardboard box with x on its side, here's a quick question, and programmers in the audience, don't answer, please. What do you think happens to the 5? When I assign 10 to the memory cell x, what happens to the data that was already there? That is, in this case, 5. Any guesses?
Is it going to be deleted?
Yes, and yes, thank you. Yes. Although, deleted is like, it's not technically the right operation because, yes?
Overwritten?
Correct. Deletion and overwriting are not quite the same thing, right? In a lot of cases, deleting something doesn't actually clear the memory. If you get down into the nitty-gritty, often what it does is it releases the memory for other things to use and overwrite. So the actual overwriting of the data doesn't occur until the memory cell is used again by something else. Which is you might think, well, I have all of this random data floating around my memory then? And the answer is yes. You do, actually. If you just take a look at the values in memory, you might expect unused cells to all be 0 or something, right? But it turns out that it actually takes time to write 0 into memory. So and you're gonna want to write something else in there anyways when you reallocate it, so most of the time, unless it's told specifically not to, the computer will just release the memory without doing anything to the data inside back to the operating system. And the operating system will just give it back out again. It will already have data in it. The trick is that data could have come from anywhere and mean anything. Even if it's something like very secure, like your banking password, like without the context to know that's your banking password, the field of memory is sufficiently large, the probability of being able to reliably hit your an old copy of your banking password stored in memory, if a malicious program were looking through your memory to try to find your bank password, it would have to try for basically millions of years to eventually hit your password. That's how vast the amount of memory it would have to comb through is. So effectively, and this is actually another this is a more advanced concept, but it's also a true thing about how computers operate. Data without context is useless and meaningless, right? It could be the most sensitive piece of data in the world. It could be the actual literal nuclear launch codes. But inside of a memory cell with no context, it just looks like random data, and it's useless. It's meaningless, right? So anyway, yes, when we perform this operation, the old values are overwritten with the new values. This means the old value is absolutely unrecoverable. You cannot get back to line 5. Once you have overwritten something, it is gone. Permanently. Destroyed. Utterly obliterated. Make sense? You can't turn back the clock. So, okay, sure. I also asked you to use the plus sign. So, I saw 2 main variants on this solution among people in the class. The first, and probably the more efficient, although efficiency, whenever I talk about efficiency in this class, in an introductory class, this is purely for interest. I am in no way expecting any of you to produce efficient code, right? Because you are learners, and writing code is already sufficiently difficult. We don't have to worry about you guys writing production level, highly optimized, efficient code. It's, minimally, you'll need to take a data structures and algorithms class to even get close to an approximation of what efficient programming practices are, right? You're not there yet. However, I think it's interesting to people to know this way of doing it is uses slightly less memory than that way. I'm not requiring any of you in any way to do that. Part of what I'm also trying to do is keep it interesting for people who already know this stuff. So, if you are, this is what most people did. Console.writeLine x plus y, which is correct. This is known as an expression. This is a statement. This is a statement. This is an expression. This is an expression too. An expression is a part of a statement that gives some mathematical operation, even if that mathematical operation is as simple as stating a number. Right? So, for example, if I wanted to turn the computer into a calculator, it already is a calculator, but I can write mathematical expressions using literals, like this, absolutely, everything's fine. You know, this is something you might expect the thing to be able to do, right? You can substitute, anywhere you have a literal, you can substitute any expression, right? Anywhere you have one of these operands, you can actually infinitely regress additional expressions all the way down for as long as you want to the line. Like, the more you do, the longer the line gets. So at a certain point, you probably want to cut it off and put it on 2 lines. But expressions are what we call recursive grammatical structures. That is, an expression can contain sub-expressions which have the same range of possible expressions as the original expression. So, basically, in here, you can put as many math things, as many operations as you wish. So that's number 1. This will work. If we execute code, oh, I have build errors. Oh, yes. Oh yeah, y is already defined. Oh, so that's actually a useful one for you to know. If you're working with one of these loosey-goosey scripting languages like Python, you can redefine variables to be different data types within the same context. But in nice, good, wholesome, strongly typed languages like C#, you cannot redeclare a variable with a different data type. In fact, you cannot redeclare a variable, period. Once you have declared a variable, it is there inside of its scope until the program or the scope dies. So, the error that I'm getting here is I have y declared up here as an integer. I'm then redeclaring it as a double down here. That's illegal, not permitted. So, execute. There we go. You can see I get my number 35. So that's approach number 1. Approach number 2 was to declare an intermediate variable like this. The net result, let me guess. Yeah. Anyway, how about you actually run them? There we go. The net result, as you can see from the output, it's actually impossible to tell the difference between those 2 programs. The only difference that you could note in them is that one of these programs is using 3 integers and the other is using 2. But integers are sufficiently small and you have enough memory that this does not constitute a significant difference. For all intents and purposes, these 2 are the same. And, while the difference between using 2 and 3 integers is completely insignificant on modern computers, it's good to get in the habit, if you get in the habit of using less memory, then you will be in the habit of using less memory when it actually counts, when it's not, 2 to 3, or it would be like 2 million to 3 million or something, right, where things actually matter. The lower down the code is, the more it's run, the more important it is to be optimized. But again, not expecting any of that for this class. Make sense? So far, so good? So, so let's talk about operators then. You have your standard set of mathematical, arithmetic operators available to you. They are, plus is addition, hyphen is subtraction, asterisk is multiplication, yeah, this one. Backslash, no, I'm wrong. This one. Forward slash is division. And caret is exponentiation. Further, round brackets function in BEDMAS fashion. So your regular algebraic rules for which operators get operated on when still holds. You are allowed to use round braces to specify that one operation or another should happen first, right? Which, as it turns out, is very, very useful in computers. So round braces are adding precedence. So far, so good? Good. This is true, the round braces give you precedence not just on arithmetic operators, but all expressions. So even things like method calls or logic operations. We'll have plenty of examples. Just know that these are in your toolkit. Any questions? So, all of these operations also apply to floating point numbers, or doubles. But I'm probably just going to say floating point numbers because doubles are a subset of the floating point numbers. So, there are some weird conversion rules when it comes to applying operations between integers and floating point numbers. The computer is designed not to lose data, right? So, if I have 7, an integer, plus double 7.4, what is the answer going to be?
It's gonna be 21 something, I guess.
Well, 7 plus 7.4 is in regular math.
Yeah, but then it says double, so is that like?
That's the data type. Yeah, no, we're not, so this is not multiplication by 2.
Oh.
Yeah. This is indicating that 7.4 is a double precision floating point number, which means that it is a number that can contain a decimal component. Whereas integer cannot contain a decimal component. In fact, if you were to assign 7.4 to an integer value, you would get a compiler error. So, I can demonstrate. 21.2. there's my error. Cannot implicitly convert type double to int. An explicit conversion exists. So basically it's telling me this is a slot the size of an integer. You're trying to ram those extra numbers in. I don't like that. I want you to chop them off first, which you can do. You can do reasonably easily, actually, just like that. That's called casting. This is truncation. It will drop the decimal component. It's not a rounding operation, right? So if I have 21.9, this doesn't give me 22, it gives me 21. This is also called the floor operation. So round means rounding in the regular sense, splitting where you round on 5. Ceiling means always round up. Floor means always round down. But to return to my question, if I have an integer value of 7 and a double value of 7.4, what is the result?
Could be wrong, it could be an error.
Hmm.
You do an integer with a double, and I think it has to be distinct. Does it not?
Let's try it. Yes. So in this case, it's an error. Cannot implicitly convert type double to int. An explicit conversion exists. Are you missing a cast? But the question is that because of the expression? Or is that because I've typed this double? Or I've typed this integer? Do I still get the error if I type double? No. So, this is what's going on. 7 plus 7.4 results in a double. You must think of every operation as an operation taking inputs and producing outputs. All inputs are typed, all outputs are typed. You must know the type of the output to know how it's going to behave. When I take an integer and I add it to a float, that output, the output here must be a float, or else the computer is losing information. What information is it losing? If the result of this was an integer? The 0.4, that's right. Right here. Let's say, just for the sake of argument, it does the regular addition. It comes up with 14.4. And then it's like, okay, this must be an integer now, right? Integers have no decimal places. When it converts to integer, it drops the decimal place. It's not going to drop the decimal place unless you tell it to, somewhere in the code, right? So, rather than drop the decimal place, it converts it. It takes this expression, and the output type of it is something that will hold all the data that went in. That is a double. So, this results in a double. I can store it in a variable of type double. Does that make some sense? Hopefully. The languages, like computer languages, are conservative of data. They're not going to drop data unless you tell them to. Now, you might, in your infinite wisdom, get an error message. Fix that error message incorrectly, sometimes even by following a suggestion given to you, right? And, introduce a bug into your program. That's still not the computer's fault, right? It's kind of like, you know, when you write a program, you are the author of that program. Everything that program does is your responsibility in a kind of a legal sense, actually. Like, for example, let's do a little case study. Ooh, we've got like 2 minutes left in class, which is just long enough. Let's just say, for the sake of argument, you're working at a company. Your manager asks you to write something for some part of the program, right? You go on to ChatGPT. That's what they're calling ChatGPT these days. You go on to ChatGPT. You ask it to solve your problem for you. You grab that code. You copy paste it into your code, which you then push out in the release version of your software. It's full of bugs, it breaks things, and the customers are mad. Whose fault is it that the customers are mad?
Person who cut corners using ChatGPT.
Well, yes. Yeah. You are a human being. You have agency. You can have responsibility. ChatGPT is not a person. It cannot be sued. Hopefully it can at some point. But even then, ChatGPT wouldn't be the thing sued. It would be the people who make and operate ChatGPT who would be sued on ChatGPT's behalf. ChatGPT does not have legal status. It is not a legal person. It cannot bear responsibility for actions. That would be you. But like even at like kind of an ethical level, if you take code you don't understand and like give it to people as your own, you are still responsible for the consequences. You can't say, oh, the editor suggested I make that change. It's not my fault, it's the editor's fault. It's like, no, it's your fault. You are responsible for your code. All right? And that is the same perspective that we take in the school to academic integrity. Okay? Anything that's on your page, you own. And you gotta own the consequences of it too. So, while these things will give you suggestions, they will not always give you correct suggestions. The corrected fix for this was to cast this rather than change the data type. This is because the system will assume that you got this part correct at least, that you put in the data types that you meant to. But that might not even be the case. It's an assumption that it makes that it might be wrong. All right? Any questions? Shall we adjourn until next week then? All right. Thank you very much for your time and attention today, folks. I know we covered a lot of material, and at the same time it feels like we didn't, but that's kind of just how we're going to have to go with this stuff until we get, past the basics. So, thank you very much.